to MySec Southfield. My name is Brett Hansen. I am the Southfield coordinator. There's other meetings if you are interested in.
Actually get off camera with that mustache. Yeah,
I'm gonna have to ask you to leave, sir.
Not great advertising. It's medical.
So we have MySec Jackson that meets the second Tuesday of the month, MySec Lansing that meets the second Wednesday of the month, MySec Southfield which meets the second Thursday, which is today, and that's why you're all here having a great time. We also, if you're interested, I have the information for ISC Squared, which meets the fourth Tuesday of the month, North Oakland ISSA, as well as the Motor City ISSA and Lansing ISSA. So if you're interested in any of those, please come on out. Thank you, David. We're also currently meeting at Town Square Food and Spirits, and please pass your thanks to the staff that provided this room and great food that will be coming here shortly. For those who have already had snacks and dinner, hopefully you saved some room. And if you didn't, please, when they bring in the food, eat it. There's always leftovers. I don't like to see anything go to waste. And also thank you to Tech Systems for providing the food that we'll be eating. Be part of MySec. If you have a topic for a talk, let me know what you would like to see. That way we can keep you interested in things that you would like to learn. Also, if you would like to give a talk, please see me. And if you haven't had the chance to join Slack, if you go to mysec.us, you scroll down to about middle of the page, there is a button for an invitation for Slack. So join the conversations. There are multiple channels for all of the different chapters, including the Gurkhan chapter that's kind of spinning up at the moment. So announcements, we have MySec Social, which is going to be at the Royal Oak Brewery on November 29th. Also, Converge Detroit is only 188 days away. We are counting down every month. It is May 16th to 17th, and early bird tickets are only $100 until like February 20th something. So buy tickets, buy tickets. If you need the address, it's convergeconference.org. We have the RUCTFE, which is this Saturday, led by James Green and several other individuals. If you need any information, please ping James after the meeting and do some hacking. Also, is there any job postings that anybody would like to share? They're all on Slack. All right, so if you haven't seen on Slack, there is a job posting channel. You can visit there, and a lot of people post right there. And then, yes?
I was going to say I have a mid-level cybersecurity engineer position and a senior cybersecurity engineer position open. I'll post it on Slack, but yeah, I'm on the lookout for it.
Fantastic. Anybody seeking jobs? There you go.
We're trying to catch on with you over in a second.
Sounds good.
All right, any special events that anybody would like to make an announcement for that I may have not known about or didn't announce? Nope. All right, so we have James Green here, the introduction to programming with APIs. Thank you.
All right, cool. Thank you guys for coming. So yeah, this is the introduction to APIs. As Brett said, I'm James. I've been doing MySec for a couple years. If you guys want, you can follow me on Twitter at greenjam94, and I'll follow you back. Try to answer questions if you don't answer them tonight. So starting this off, we'll get through some of the basic technical details about what APIs are and what kind of makes them up. So off the bat, what does API stand for? It's a application programming interface. Again, it's never going to get spelled out. It's just a terminology for you. More specifically, I'm going to be talking about REST APIs instead of getting into SOAP APIs as well. REST is representational state transfer, just a framework which uses HTTP protocols. It's really similar to how websites work, so I'll be going into that a bit to get us started. All right, so right off the bat, to kind of tell you about APIs, I'll give you a brief overview of how websites work. So when you see a website, it's meant for a user to be looking at it, right? If you go to a web page, it's going to have text and images and fonts and colors to make it seem inviting to you guys, right? That's all built on the response after you send a request to the server to get that information. Basically, when you're dealing with APIs, you're not going to get any of that fancy front-end stuff that you have to worry about. There's not going to be colors, there's not going to be images. It's just going to be the data that the computer itself would care about. So again, let's go over the basics. So for headers, right, basically they're just name-value pairs when you get down to the code. So you're going to have some variable, it's going to have a name, for instance, size or date, and then the value for that. So when you send a request to the server, some of the common headers that you'll see is like the client IP, that'll be your personal IP address, the browser version, so Chrome or Firefox and the version that's running, that'll be sent to every server, every website you guys visit that's being sent out, as well as any cookies. So when you log in, you'll get a ID or a hash that says who you are, and that'll be saved as a header and sent with each request. When you get a response from the server, right, there's going to be more headers as well. There's going to be a type. Normally it's saying like what kind of response it is, so HTML or some kind of data format. The date that response is coming to you, as well as the size, so the client knows how much information is coming in before it displays it to you. Probably the most important thing for the terminology that we're going to go over is the HTTP methods. I'm not going over all of them, just the real common ones that you're going to see with APIs. So the first one is a GET method. This is what's used when you're getting information from the server. So just imagine anytime you're pinging a website to get data, you're using a GET request. Post requests is when you're giving information to the server to save that information or create new resources. A put method is used for updating existing information. So if the record already exists and you're changing it, if there's like a typo or something, that should be using a put method instead of post. And then self-explanatory, there's the delete method. So this is just, you want a record deleted, you're saying this is okay to get rid of, and then the server gets rid of it. Special caveat, so again, there's supposed to be these four methods that you use, right? If you're updating data, use post or put. If you're getting rid of it, use the delete method. I've seen crappy APIs where everything is a GET request. So you can say, like, get profile, and then extend it in that URL is update, and then you're passing in queries where, like, new name is James, and that's how the server updates things. Git can do everything if that's how you design it. Don't design it that way. Use this framework. Use the different methods. All right, cool. Hopefully the colors show up in the back. So again, going through the different parts of the URL. Scheme is just the protocol that you guys are using. So whether or not it's HTTP or HTTPS for the most part. Host is the domain or the IP address that you guys are using. So twitter.com, that's your domain. If you're doing something local, that would be, I don't know, 127, like localhost or something. You just use an IP address. The path, or sometimes called the URI, is just the rest of the URL after that, before the question mark. That tells you what part of the application you're going to. For the API, it tells you what section of the API you're using. So sometimes, I don't know, the same API could have something for like records and users, and that's normally denoted with like /users or /records. So that's just a way to help clarify what you're trying to do. And then the query is just, again, a name-value pair. Name equals the value, where if you're doing like a search, this is your search terms. If you're passing any parameters that's not fixed for each request, it's going to be passed in as a query that way. So any questions about URLs or how those are built?
Which part's the TLD?
What?
Which part's the TLD?
TLD.
Top level domain.
Oh, top level domain. That would be the .com, right? Yeah, man. Put me on the spot. All the acronyms. Yep. So.
Are you going to be going into how to do multiple variables at a time?
Oh, yeah. So for the query, right?
Yeah.
Yeah. So if you do, that's a good point. If you have multiple queries, another character that's important is just the ampersand. So that'll be used to separate two different ones. So here we have like articles and then the tag for MSF. If you wanted a second query, you just do ampersand like ID equals 2. That would be your tag and then your ID. Yep.
So fragments part of the query, or are they separate?
Fragments?
Yeah, fragments, like the hash.
It could be. So if it's something that you're passing in, it depends on how each API is built. But, yeah. Cool. All right. So just real fast, right? When you have a web request, that's what you as a client is sending to the server, what you're reaching out for. And then when you're getting a response, that's what the server is bringing back to you as a client. And then when you're getting that response back from the client, there's a bunch of common status codes that really help with debugging if you're playing around with APIs for the first time. So your 200 level status codes are any kind of success messages. 200 is the common one. 201 if it's creating new info or stuff like that. It's always going to be 200 if it's a success. 300s are redirects. So if you get a page, you're redirected to another one that'll be like moved. That's normally like a 301 or 302. Client errors, if you give the wrong information to the website or do something wrong on the client side, the server doesn't know what to do with it. It'll respond with a 400 error. So for instance, if you type in the wrong page that you're trying to go to, you'll get the 404 not found. Everyone's seen that. And then the server side is when the server is messed up and it's on the server side. So you put in a value that's not accepted, it tries to throw that at the database freaks out, it'll say 500 internal error, and that's when things are normally getting juicy for us if we're attacking it. But yep. And then if you want to know more about the specific ones, like I was saying, there's 201, 302, 404. All these have a specific term for each of them. You can find this pretty much anywhere online, like Wikipedia is a good one with a giant table of them all.
Hey, James?
Yep.
I'm really disappointed you didn't reference the I'm a little teapot status code, 418.
14. Yeah, I should have done that one, but no, went over this too quickly.
What about the legal status codes?
Legal status code? Not off the top of my head, sorry. All right, so, all right, another common term that'll just get through real fast, or is anyone not familiar with HTML?
Tough crowd today.
All right, yeah, tough crowd. All right, so hypertext markup language, just do this in 2 minutes.
Oh, this isn't, oh, never mind, I got it.
All right, everyone's getting out of here. Yeah. Just get the shock collar ready so when they start asking questions.
I failed you all.
No, you're good. All right, so we'll just skip through that, that's fine. Does anyone not know what JSON is then?
It's right there.
Okay, everybody. Yeah. Okay.
I thought these were soap APIs.
Nope, yeah, everything's RESTful. I don't want to deal with SOAP. Just it'd be too long. We'd be sitting here for a while. But yeah, so basically it's just, again, easy for us to read, easy for computers to read. It's like a mix of both worlds. Quick example, this is probably what you care about, is if you're ever writing it by hand or something like this. Again, it's just a name value pair. Yep, and that's how most APIs will respond data. So what's the difference between a website and an API, right? So first off, this is the first live demo, and hopefully everything works.
Yeah.
Yep.
I was like, did you actually? Yeah, you did it.
Yep, actually did it. Yep. So again, this is the web page for Shodan. For those that aren't familiar, Shodan's like a giant web scanner that tells you all servers, websites, the ports that are running, information about it. So just the first thing I grabbed off their front page was like a list of all the Minecraft servers that are running. So yeah. Don't be attacking people's Minecraft servers if you see them on this list, right? Yeah. Yeah. So just to clarify, when we pass in this URL here, right, and we hit enter, what that's doing is that's going to shodan.io. The path is search, and then we're passing in our query term, and that's searching for Minecraft servers with a port of 25565, right? So that's just common Minecraft stuff. The response that comes back, it's going to have 200, okay, we have that information, a bunch of headers that we don't see here, but the browser takes care of, and then the message body itself, which is the rest of this page. So all that fancy stuff that humans care about, we have links to other stuff. We have JavaScript that changes color so it knows what you're coming over. It's got images that you can interact with, links to other pages, things that make it really useful as an interface, right? So going back to this. As far as the REST API, again, all that is gutted. We only care about the data itself, and that's going to be returned as JSON. So again, we're sending the same GET request, basically, the same URL, the same query, but we're only going to get back data. So hopefully that's not too blurry, but this is Postman, and again, we're using the same, you're not going to see a mouse. We're using the same URL, where it's just shodan.io, but this time we're using the API of it, and then we're going for host, search, and then a query at the end, which says the same thing, Minecraft server and the port. So doing this, instead of getting the whole web page back, we just get JSON data, and that's going to have the same information, where you can see the product, the internet service provider, the organization. Anything that Shodan provides to the website is also provided on the API here. So, okay. So a better demo than just showing you a screenshot of what Postman is, right? We're going to go back and take a look at that, and then we're also going to go over the Pokemon API. Right, because everybody loves Pokemon, right? Hopefully. It depends. Nope, not Pokemon Go. We're just playing with the API to get information, right? So
Before you move on,
that's true.
the Shodan.io URL that you used at first to enable web page.
Yep.
Let's say I'm using Python and I just type that in a request.get. Because I'm not using a web browser like Chrome or Firefox, would I get my JSON back? Can you talk about what that looks like?
No, so if you use Python and you just went to Shodan.io and that URL that we used in the browser, you would get the response headers at first, and then you would get everything as HTML content outputted as Python output. So that'll give you all of your, it basically gives you the page source. So if we click.
So what you're saying is that just because I use a programming language, that doesn't automatically make it an API?
Correct, yeah, exactly. Just because you're using Python or just because it's using the command line, for example, even if you curled the page, that's not an API exactly. You're just scraping the website content. So it'd be similar to right-clicking and then doing view page source and then just seeing all of it as HTML content. So this is what would be spewed out onto your Python or command line interface. Right. So, and again, that's all messy because you're going to have all the HTML tags, all the links to other stuff, all the links to CSS. It's not data you don't care about, so you'd have to figure a way to parse through that and get rid of the things you don't care about. So this tool that I took a screenshot of, this is the actual full screen version of it. It's called Postman and it's offered by Google. It's a really good way for manually practicing with APIs if you've never poked at the endpoints before. So first way to do that, again, we're going to look at the Pokemon API. And I have these saved requests off on the sidebar, but basically the important part is you can enter the URL at the top, and then any parameters that you're passing in, you can enter beneath it, and then hit send. It's real easy to switch what kind of method you're using as well. So get, post, put, patch, delete, a bunch of other ones that I didn't talk about. What's up?
Can you actually correlate and save your different calls under certain categories within that tool?
Yes, you can. Yeah. So I'll go through that in a bit. But that's kind of what I've already done on the sidebar is ones that I was testing last night, the ones that I know worked, I saved them to collections. And then all you have to do is click it, and it'll load that information you saved back up into the page. So, and again, the reason why we use Bulbasaur, even though he sucks, is because his ID is 1, right? So, it's true.
Nobody picks Bulbasaur.
Nobody picks Bulbasaur. It's true, though, right?
Just reel it in, man.
Right. So when that loads up, you're going to get all this information about Bulbasaur, right? So you're going to get its abilities, its name, the forms it comes in, the level, the like the experience level that it evolves at, all this great stuff about Bulbasaur. If you want to get a different Pokemon, right, you can change that 1 to any other ID, but nobody really knows the IDs for these Pokemon. So you can change it to just the name. Yeah, you could change it to 2, or you could just type in Charizard, right?
And you read that already?
Yeah, I saved that one when we did name, but when you run it, it'll do the same thing. It'll return the same output, but just for a different output.
Does missing no function? Missing no?
Probably not. One way to find out.
Negative 1.
Yeah. So if we want to, -1 is just, yeah. So this is when it starts kicking out error messages when you do something that's not there. Yeah, exactly. So there. So yeah, again, Postman just makes it real easy to, again, play with different queries that you want to pass in. If you want to try something that shouldn't work, this is a great way to just do manual testing. It's a lot simpler than trying to do it in the browser or anything like that.
Real quick.
Yep.
So with this, does Google go out and find the APIs that it then supports? So what if I built my own API and I wanted to test to make sure that it works? Should I use that here?
Yeah, so this is not integrated with, like, Google. It's not doing anything weird. It's still using a regular HTTP request to go out in a response. So instead of a browser, we're using this tool, right? So any API, any website, it'll try whatever you type in. So I could change this to, instead of Poke API, I could try to go to Nintendo.com, and it would probably give me an error message or just the web content back, and it might try to format it as JSON, but it'll probably just give me the raw message and say, like, hey, this is HTML. Yeah.
So is this really just some sort of manual fuzzer?
I wouldn't even call it a fuzzer. I just call it another like a replacement for a browser. It makes it a lot easier to change the methods and have more specific control over certain elements. For example, if you try to do that get in a browser, it would return the JSON. But if you had a post request to update something, maybe they misspelled the name of the Pokemon and you wanted to fix it, you can't really do a post request in a browser alone. So Postman, you can do that. Just change the method and go from there. All right. Cool. So going a little more in depth into that, right? So tools to use an API. Really, you can use anything as long as it allows you to track or modify headers, the URL itself, or certain parameters. So browsers are really common for that. Postman is great. That's what we just went through. Curl works. That's a command line argument or something on the command line you can use to just go to a website, get information back. Also works for APIs because, again, it's that same request response interaction. So anything that can send a request over the HTTP protocol, that's basically what you're looking for if you're trying to use a website or an API. For example, you could use Burp Suite or OAuth Zap. I tried this with the Pokemon API, and this is my result. So again, it doesn't look super good, right? And it's too small for you guys to see. Basically what matters is I changed the ID from 1 to 2, and then I looked at the output that came back. Instead of it just being JSON, it gave me that whole request message, and it was all in hex. So you get the hex values of the response, and then 1/3 of the screen showed you that JSON, and it was all smashed up and looking weird. So it could work with Burp or Zap if you wanted. It just looks like crap, so I wouldn't suggest it. All right. Okay. So that's a lot of the. All right. That's all the basic terminology and how APIs work. Is there more questions on that? No? Cool.
I mean, the real key is just not telling me.
Right, that's true. Yeah. All right, so once you've figured out what an API is, the first thing you want to do is write a script or find out some way to use that API for yourself. Get the data that you want from the service, right? So historically, APIs were used for server-to-server communication. Another term you might hear is like business-to-business interactions. So nowadays, imagine if you create a new website and you want people to log in, but you don't want them to have to create an account. You can have them use their Google account to sign in. For the developer making that website, they can use Google's API to just set up that authorization process, where they type in their email and password. You, as that server, send it to Google. They confirm. You get a response back, and that's how they authenticate through the rest of your website. So anytime where it's, imagine a server to another server, that's how APIs kind of started out. But now they're coming out more public where people can use them as clients. Yeah. And the logic is pretty much similar no matter what. So if it's server to server or you as a client to a server, you're writing the same kind of script. It's the same kind of code. All right. So going over how that logic works, the first thing you want to do is try to find some kind of documentation. Hopefully it exists. So for example, if you want to figure out how to scrape Twitter, right? You go to their developer docs, they have their API reference manual, and it says, here's all our endpoints, here's the ones where you have to use get method, here's the ones where you post, and it's all explained for you, right? Not well, but it's enough to get started, right? So, if at all. The first thing you want to check for when you're looking for that stuff is what's the endpoint you're specifically using. So this is going to be the URL and the terms that you need to pass in. All right. What parameters are required? So if you need to pass in your username, if you're trying to get specific user stuff, if you're trying to limit the number of tweets you're getting back, those are all parameters that you can get passed in. If authentication is required or not, this is kind of a mixed bag. A lot of the public APIs require you to have some kind of account where you authenticate, get a key, and then you use that key for future requests. Yeah.
2 questions. One, you say what parameters are required. Does that imply that APIs may have some parameters that you have to pass always versus some that are optional?
Yeah, exactly. So again, that's where the documentation comes into key. So for instance, Twitter might have a like a profile endpoint where you can get someone's profile, you just need to pass in their handle, right? If you don't pass in a handle, they don't know what profile to grab. So that would be a required parameter. There's optional ones where, again, you could limit it to a number of tweets where I only want 1 tweet returned. So it's the required profile and the latest tweet. So those would be the difference between like a required and optional parameter.
And for the authentication that's required, are those things like bearer tokens and OAuth 2 or 1.0?
Yeah, exactly. So it can either be a bearer token like that, something where you give your username and password, you get a temporary token back, and you use that almost like a session with that API. Or you can have like a long-term key that's just an API key that they give you when you log in through the website. And that's kind of just like a, I don't want to say hard-coded password, but it's open for a longer time. And you can use that key to get the information back because that's how they're saying you are able to use that API.
Those long-term keys, should I try to keep those secret in some way?
Yes, yeah, definitely. You don't want that getting out because basically if you, I don't know, publish your script to GitHub, not that I've done that before, people can get that key when they look at your code, right? And then they will run that script, and instead of them, you know, getting they'd still get their own profiles because they changed that handle that they're searching for. They can get somebody else's tweets. But as far as Twitter cares about, it's not Joe Smith getting his information. It's James getting it for this other person. So it's on their end, it's me doing it all. So great for hackers, not so great for the developer that's stupid.
The best way to do this is to get all your API keys from GitHub scripts.
Yes, exactly. So Google Foo, find other people's keys, use those.
I've been looking for a virus total key forever.
So it does say the bandwidth is cheap, but still, don't most APIs end up kind of having some kind of paid tier or start kind of watching how many calls someone makes? So it's another reason if someone makes 10 million calls on your API key,
yeah,
to call you, know what the hell you doing.
Yep, that's true. That's actually, so going back to that first Sheldon example where I had the screenshot and you had the red bars through my API key, if I didn't have that there and I just had it shown up here for the stream, somebody could be using that right now to do a bunch of scans on my account and burn the 20 free tokens I had from signing up. So that's another good point.
Some of the APIs too.
Person with their laptop out.
Yeah. I see. Great.
Some of the APIs too, like I had to deal with Google Maps recently because like they completely got rid of their nonprofit thing, and I kind of redo all our maps like with like a day's notice. And with that, like if you're doing JavaScript, like you have to have it visible, so you can like lock it down to like a certain like domain or something like that in their tools.
Yeah, exactly. So
you can also, advice from you, you can also put everything in a configuration document that's completely separate from the script. So you can have the script call the config and obtain the details and parameters from the configuration text document.
yeah, exactly. So you don't have to save that key exactly to the same text. It could be in config, it could be in your environment variables. There's any correct way to save a secret without broadcasting it everywhere. That's how you should be doing it, right?
You don't have to hard code it if you're dealing with multiple scripts and multiple APIs. You can just call the configuration text file.
Yeah, exactly.
Safety boxes in worship.
Yep. All right. So again, going back to parameters, when you have a script, just pass it as input. So when you're running the script, next word you type in is your input. And then when you're writing out your script, write the request, get those parameters set up, do the authentication, and then whatever that returned as, it's going to be the HTTP response with JSON data. From there, you can do whatever you want with it. You can save it to a file. You can parse the JSON if you only want like the times a person tweets. You can get that specific time field and then print that out from the Python script. So many things you can do, whatever your mind imagines. Right? Cool. So another thing that really helps out with developing scripts to use APIs is wrappers, right? So sometimes it's the same developer, sometimes it's a third party, but this is, again, just a library or a code source that kind of wraps up the whole request response objects into a class, where it makes it really simple to just use an API. So instead of having to import HTTP request and then do all this other stuff and do it all manually, you can just install the library or the wrapper, however it's made, and use that to use the API. So for example here, going back to that Pokemon API from earlier, somebody has a Python library where it's just importing Pokemon, and then from there it's as simple as creating a client which handles your HTTP methods, the request and response objects, and then you just call get Pokemon, and that's going to do that first Pokemon request for you, and it'll type out that whole URI, send all that stuff, and then just spit out the JSON data, because that's all we really care about, right? If you want to know more about that specifically, there's the GitHub link. It's all up there, open source. You can read through how that's been built.
James, is Python the only language that allows you to use API wrappers?
Yes.
Yeah. So going off the room, the answer is yes, but I'll tell you no. Any coding languages, you can write a library. It's just that's the...
Questions. I don't know about you.
Yeah. That's very pointed questions in the room. That's fair.
Actually answer that for us?
I may
Yeah.
or may not just be asking questions to guide conversation.
That's good. Yeah. Conversation heckling is the same thing. Very good. So...
What's that? How did I pick up on this? Some people didn't. For the room's record, I'm not stupid.
Actually, that's on camera? No. All right, so...
I think the hostess will disagree with you.
All right, so another example we have, right, besides using the Pokemon API is, again, if you wanted to get all the tweets from a specific person on Twitter, download that to a file. It's all in this gist. I cut out parts just to make it all fit onto one slide. But again, it's highlighted to match where green is the parameters. So when you call that function, pass in the screen name. Red is how they set up that authentication to let you know that you're allowed to use Twitter. So that's here it's hard coded into the script. Not the best practice. Don't put this on GitHub yourself. And then the blue is the endpoint that we're using. So the wrapper is just saying to use user timeline. That will go out to the specific endpoint that Twitter has for that, so you can get their entire timeline. Again, passing in the parameters, and then at the very bottom of this loop, because it takes multiple pages to get the entire timeline back, it's printing out a message saying it's saving that all to a file, right? So this is just one example that you could use to write a script to use Twitter. And again, it doesn't have to be Python or anything like that. It's just whatever language you're comfortable writing in. Yeah.
Just to add on that, if you're new to APIs and you go down the Postman route, that's how I learned to first use them. You can export them in any of 7 popular languages as actual scripts, and you can see how they're written in those languages that you export the script out of. So you'll be able to pretty much have your base foundation, and you can build from the API documentation to get a better feel for how API calls work with that specific language.
Yeah, exactly. And that's actually a really good point, so I'm going to repeat it just closer to the microphone for the stream. Postman has an option to export these script parameters, so you can just take the API call itself and have that exported to 7 popular programming languages and have that sent out for you. Cool. All right, so this one's hopefully going to go fast. I only have a couple slides on this, but if you wanted to make an API, so say you're in charge of developing a website, or you have a product that you're trying to get data out about. Steps to go through building an API, right? First, you want to design it. Just make sure that you know the data that you have in your database. How do you want that to be accessed? So thinking in the terms of the method types, again, get, post, put, delete. How do you want that data accessed? So if it's a database of users, how do you want that to be received? Do you want them to get a specific user at a time, just a list? Do you want the whole table dumped out? A lot of this is just how you want to develop it, but those are things that you want to design first before just trying to implement something. This is super short because it's really in depth, but next step is just build it. It's easy, right? Pick a language, whatever you're comfortable with, probably the same language that you're using to build the website. You can do it in PHP, Python, Node.js. Anything that you can use to build the server-side code, you can use to build an API, right? And then just for starting out, if you've never coded before, I suggest looking at Node.js just because it's mostly client-side code anyway, and the server-side stuff runs in an API format. So if you've never touched server-side code development before, take a look at that. And then test it, just make sure it works the way you expect it to. If it doesn't, figure out why. That'll help you either fix the issue when you're making it or understand what you were missing when you were designing it. Yeah.
So why would I use a get versus a post versus a put versus a delete?
Yeah, so that's, again, it all comes down to like a framework standard of how those methods should be used. So you can force everything so it's only using get methods. You just should never do that because there's a standard that says get should be used for receiving information. There's a standard that delete should be deleting information. If you only use one method, then you could make it work. It's just not going to fit the standard. And when other developers try to expand on it or write a wrapper for it, it's just going to cause a lot of headaches, right? Yeah.
Is it safe to implement a delete statement in my API if it's public facing?
If that's what you want to do, yes, it's safe. If you want anyone to access your public API and delete information, sure. I would strongly suggest putting that behind authentication so you make sure it's the right user. But it depends on the scope and what you're trying to do with that API, right? And then, of course, because nobody does this in the first place, make sure you write documentation so if it is public or not, your users know how to use that API after you've built it. Okay, cool. So hopefully this is the part that more of us being security focused care about. It's actually hacking APIs, right? Started off with the usual caveat. Again, if it's other people's APIs, if it's not yours, if you don't have consent to do it, don't attack it. It's a good way to land yourself in jail or get in trouble. Define.
Can we abuse it?
What?
Can we abuse the API, not necessarily hack it?
To a degree, sure. Yeah. I mean, again, where that line gets drawn between using an API and hacking an API, I'll let you guys personally decide that. I'm not.
Very gentle with the API. You know?
Yeah, if you want to gently caress it as you're attacking it, that's your call. I'm not going to go into why that doesn't work. Depends on the day of the week, right? Yeah. So, yep. All right. So the first point that I'm going to make for this is that obscurity is not security, right? Just because people can't see it doesn't mean that it's secure. So most APIs are not built for public use. They don't share the documentation. They don't give it out to everyone to use to create their own scripts, right? So that being the case, the developers think it's secure. I have this for the back end. Nobody uses it. They just care about the web page that they see on the browser, right? That's not the case at all. So first story is the Venmo API. This is actually something that's still an issue. All of, I don't want to say all of. By default, Venmo has a transaction backend that uses a public API. So if you guys use Venmo and you haven't set your settings yet, whenever you send somebody money or you receive money, that's sent across a public API and anyone can see the history log of what's happened. Right?
If you mark it private?
If you mark it private, then it goes to a different service. Yep. So that's why it's still an issue, is because they're saying, oh, this isn't our API, it's your user settings and you've chosen to be public, even though it's the default setting. So hopefully this works.
That little emoji of trees, what do you think they're
Yeah, they're just trying to break stuff. Yeah, of course. So hopefully this one works. Again, this is just going to venmo.com/API and then public. So this should get a list of all the public transactions, hopefully. Yes. Okay, cool. This actually worked. It wasn't working before I started talking, so this is good. Again, this is just spitting out all of the JSON data about the most recent transactions. So for example, we can see that Brent sent money to Safa. And you can see the ID.
Does it have a reason?
Yep. Well, it has a message, right? And sometimes this is blank, but here this is saying the message is beanies, right? So you don't see the amount, you just see the timestamp, the beanies. Yep.
Beanie Babies. Oh.
Yep. So beanie babies or a hat, something. I don't know. Yep. Yep. So again.
Yeah. Over 1,000 if you want some.
That was Brett's account.
Yeah. So again, this is just. Again, this is kind of a good example of where you're kind of towing that line of are you hacking it or not. Here, it's a public API point. We're just hitting an endpoint. We're not sending any malicious inputs or anything weird like that. We're just using a public API to get this information, right? So it's getting close.
What was the call that actually, like, how much data did you pull?
Oh, it wasn't unlimited, so it's just the first page that the API responds. So I'm not sure if you can read it, but it's https venmo.com/API/v5/public. So again,
I don't see any identifiable personal information.
no, just a name and stuff like that, date. It's not too, yeah, it's a little bit of PII.
Full name? I thought it was only the first name.
Yeah, it's first and last.
You can't what? No.
I thought it was just.
No, sorry.
And it might even be. Okay, I got it.
We do a little bit. Is that better?
Yeah, it works.
So you can see some stuff. You see, yeah. So some PII. Yeah.
You just want to
All right. Yeah. So again, you can use public APIs to get some interesting information. If you guys want to go back and mess with Venmo or tell them this is a bigger issue than they think, go ahead. But this has been out since 2015, so that's why I said it's safe to do this. But again, that's my personal call.
Can I use that in court? It's safe to do this?
I didn't tell you it, but go ahead. That's true. Yeah. I'm gonna go back to that other slide where I said don't do anything illegal. So how about that? I'll cover my butt. So
this is like the weirdest Weight Watchers thing I've ever been to.
yeah, it's a good talk. Yeah. Yep. So again, going through some of the more common APIs, we already talked about missing or broken authentication. So for Venmo, it's just completely missing. They have a public API entirely. Another example that I can't show you because they fixed it was Salesforce. They pushed out an update to their API where they didn't authenticate correctly between different users. So you had access to the API, you didn't have access to which user's information. So you could just change the user ID. From what I read, you could just change the user ID and then start changing other clients' information. So not sure how long that lasted, but that was fixed and patched. And if you want, you can go to darkreading.com and figure out more details for yourself.
It's not like only if they're exposed to the internet, not like a company's private Salesforce infrastructure.
You had to have an account, you had to log in, you had to change your ID.
Yeah, that's true.
All right.
Yep. So yeah, you did have to have a actual key, which is a good point to make. So it's not just anyone could do this. You have to user A attacked user B, not hacker in Russia attacked. Yeah. Yeah. So another common vulnerability, right, is man-in-the-middle attacks. So insecure transmissions, all the APIs are just built to get them working. Again, if it's on the back end, nobody cares about it, nobody sees it. You don't update the TLS cert, you don't put a certificate on it, and it's just sent in plain text, right? So if you're common with intercepting that HTTP traffic, you can see all the endpoints they're using, all the data, all the JSON going across the wire, and then you can use that to either modify it, pick it up, go from there. And then all of your common injections, so SQL injections, cross-site scripting. If you can see the requests going through, the parameters they're using in the queries, the additional parameters in the body, you can modify those. If you're expecting to see the ID of the Pokemon that you're sending and you change that to -1, does it break the server because it's thinking too hard? Does it just respond an error message? If you change the -1 to little Bobby drop tables and just try to wipe out the whole database, right? If you do SQL injection, there's a lot of different ways like that where you can try it, right? So when you're trying to find these API vulnerabilities, right, first thing you want to do is, again, go back to the documentation, try to figure out what they intended to do, and then from there, try to break it. If they say, here's all of our endpoints, but you need authorization and like you need an API key, what if you don't use a key? Does it still work? Like just test it to actually make sure you can hit points. From there, it's going to be a lot of brute forcing and a lot of fuzzing. So again, changing the ID parameters if you're expecting an ID, changing the search terms you're using, maybe try different encoding. There's a whole bunch of different options you guys can use to attempt to break the API or just get a different result than what they expected to return. All right. Okay. And again, so if authentication isn't implemented correctly, if they try to do something in-house, just attempt with, I don't know, if you have two different API keys, does it take the fake one or the real one? Can you give yourself a second key? Like just try to mess with stuff if you think, based on the documentation out, what?
Variable tampering.
Yeah, exactly, variable tampering, thank you. Just keep messing with stuff. And then, so yeah, just again, to wrap it all up, if you try it on a website, you can also try it on an API. So a lot of that is very similar. Cool. And then going to the last bit, I'm telling everyone how this stuff can be broken if you're trying to attack it. I'll quickly try to go over how to fix some of these vulnerabilities as well. Right? So in the end, just use duct tape. That fixes everything. For all the injection attacks, you want to use just validation techniques. So if you're expecting an ID to come in, make sure it doesn't contain letters in it. if it's just a numeric ID. Make sure it's not negative, stuff like that. Just it could be as simple as a bunch of if-else's before you're actually using that data when you send it to your database. Right. Set up test cases for common injection as a developer. So as you're building stuff, expect people to poke it, expect them to send wrong parameters, expect them to test the limits of the API. Write that yourself so you're breaking your own stuff instead of somebody else breaking it. Right. Always implement TLS when you're doing this stuff. Don't send anything in plain text, right? Make sure the HTTP requests are encrypted, all the traffic. Yeah. Oh, 1.2, that's fair. So again, old TLS is outdated. You can crack it, so use the latest and greatest whenever you can. 1.3. Or 1.3, that's true. Yeah. And then again, when you have APIs, implement some kind of authorization and authentication. Yeah, I got a quick point against the two. A lot of the time when people say implement auth, they mix these two terms together. They're not exactly the same thing. So authentication is saying you are who you say you are. Authorization is saying you're allowed to do the action you're trying to do. So for example, if I'm saying, like I'm James on the Twitter API and I'm trying to send out this tweet, the authentication part of that is saying I'm actually James. Authorization is saying I'm allowed to tweet as that account. Right? So make sure both of those controls are implemented correctly. And then again, don't build anything your own way. Follow existing solutions, follow frameworks. So instead of figuring out what a Git method is and then making everything work to that, see how other APIs are built, how people are using it, use those solutions, use those frameworks, go from there. Okay. So pop quiz for everybody seemed like it'd take us too long, so just a quick summary, right? What new buzzwords do you learn? You don't actually have to answer, but again, just thinking back to what we were talking about earlier when we were going over all the terminology. What did you learn about HTTP, stuff like that? What can you use to apply there? If you haven't already played with Postman, go and do it. If you have an API, just go poke at it, try to see how it's used. Postman's probably the best tool. When you install it for the first time, it will pop up with Google and say like, hey, sign in with a Google account. You don't have to do that. There's a grayed out link at the bottom that says, take me to the product anyway. Just click that so you don't have to create an account. Yep. And if you have, a lot of you guys already work with existing security tools. Those have API, well, most of them have APIs. We took a look at Shodan earlier. Right, Splunk has an API. Fortify has an API, which I used to use. That was a vulnerability scanner. Again, if you just want to automate your job so you have to do less, you can use the API to say, okay, every Monday morning, start off this scan. Every Friday, download the results. So 2 days out of the week, you don't have to do anything. It's amazing. And then, yeah, exactly. So this goes back to that scripting yourself out of a job. So just don't tell your boss and you still have a job. And then again, Twitter, Slack, a lot of tools these days have APIs that you can mess with. So go find one, play with it. And then if you have a project, if you're a developer, go and try to build an API so it's not just a website, but you can have the data side of it too. It's a great experience. And then if you want to go try to poke something, go bug hunting against APIs, but get consent first and don't do anything illegal. Any questions? Yeah.
So that being a little more on a deeper end in terms of best practices. So I'm playing with APIs now, I'm pulling data sources, everything's going my way. Now I have an abundance of data that I need to find an actual sustainable solution for if I want to continue playing with APIs. How do you recommend processing the JSON files? What kind of databases would you recommend starting off with in terms of dumping the data into? How do you correlate all this data that you're pulling to essentially make something actionable or intelligent or produce intelligence?
Okay, so that's, we could spend the next 3 hours talking about that, or could just say it's different for each user, right? So if you work for a giant corporation and you have 30,000 endpoints that you're pulling JSON results for all of them, you're going to want like a high performance database. You're going to want to have some solution that you talk to your development team with or your security team and just work something that works for everyone. If you're just pulling the tweets from today's logs and you want that as JSON so you can quick through stuff, that could be a SQLite database or something on your computer where you can just wipe it afterwards.
We always use Excel.
I'm not going to repeat that one, but yeah. So it's specific.
So a lot of people ask your question, right?
Yeah.
A lot of people ask that question, and reality is that there's really only a handful of really good ways to manage that kind of data. You know, I know a lot of people are using like Elasticstack, things of that nature, to be able to correlate those things fairly quickly. But realistically, I mean, even with like 30,000 endpoints, I mean, even something as simplistic as like MySQL, Postgres, I'd probably say Postgres would be better, but will do what it is that you're asking. And even at that, I don't think 30,000 is going to overwhelm that. So I think the vast majority of the solutions is what I'm saying, to kind of clarify his answer, that are out there and available, you know, mostly for free, will do what you're asking. It's just a matter of what you feel most comfortable with, whatever your knowledge base encompasses.
If anything, you might want to do like more of the object databases, because those are a little more dynamic with like the JSON objects that can change. Whereas SQL's kind of structured a bit more.
Your mind would use WebScale.
Yeah, whatever floats your boat, you can make it work. So, do you have another?
In all of the times that you were talking about the output that's returned, you kept saying that it was in JSON format. Is that the only type of format that gets returned?
It's the most common one that I've seen. I'm pretty sure that's the standard, is just to return in JSON. I'm sure some developer somewhere did something stupid and can return something different. But before the framework, yeah. I don't know.
For clarity,
that's biased.
I've dealt with a lot of APIs. Some of them will return XML.
Yep.
Some of them will return CSV.
Yep.
If they have those formats, to James' point, they will also most likely return JSON, and you can specify the type that you want returned. So if you're already dealing with a lot of XML or whatever else, type will typically be a parameter that you can pass, where you can specify CSV, XML, JSON, and those kinds of things. So whatever you're most familiar with, but I would recommend working with JSON because the key value mapping is very easy.
The JSON is cool.
Yeah. Cool. All right. Anything else?
Thank you for taking the time to do this.
Cool. Yeah. Thank you.
Thank you.